How to rule Jenkins with configuration as code. Actually, there are many talks about Jenkins and configuration as code, but none of them tell you the whole truth. How does this work in real life? I will give you an answer to that and show an example on how to successfully introduce the Job DSL plugin in a real-life, medium-sized company. The Job DSL plugin is a great approach, and there is an even better way on how to use it. And I will show how we managed to migrate hundreds of Jenkins jobs to automate almost all Jenkins configuration without breaking the IT process or affecting quality and stability. Configuration as code does not solve all configuration issues. There are a lot of problems and pitfalls people have to look out for. This talk is not about the Job DSL plugin in detail. There are some great talks that cover the subject, so please refer to them for further details. A little bit about myself. I'm a DevOps engineer. I work at Payback. That's a German company based in Munich. I'm the Jenkins and Nexus administrator, and I'm the main build engineer for the continuous integration and continuous delivery processes within the development department. Payback, a German company, is acting international. We are actually also in Poland, Italy, and India, and even in Mexico and the US. What we do is Payback, well, that's basically the biggest loyalty program and largest multi-channel marketing platform there is. The idea is there are a lot of partners within the Payback program. And you go to the partners, buy stuff, and you get redeem points. And afterwards, you get reward points. And afterwards, you can redeem those reward points at any other partner there is. And last year, we launched a product also here in the US. It is named Plenty, not Payback, for obvious reasons. And yeah, maybe you have heard of it at one of our biggest partners like AT&T or ExxonMobil or Macy's or whatever. Okay, let's get to the interesting part. So our first question is, why is configuration as code so important? And what are the benefits? And the thing is, when I got this job, I was given a huge Jenkins instance with a lot of jobs configured manually. And there are actually a lot of questions coming up automatically, like, for example, what is this job even doing? Or is the job still in use? Who's responsible for these jobs anyway? And why is it configured that way that it is? Are there any standard settings I have to look out for? Or who changed what and when? And this, by the way, goes far beyond the job configuration history plugin. And of course, how do I change settings for a bunch of jobs? Like, for example, you switch your repository location, and now suddenly you have to reconfigure all of your jobs that use this location. Hopefully, you do not have to do this manually. So there are a few possible solutions for this issue. For example, you can do this via the script console. But maybe you notice this is very risky, and you have no real, let's just say you can't test what you're doing. Then there are templates. Templates are great for companies who have simple job configurations, like just build, test, and deploy. It's for our intentions, this is way too static, and also you can't test this stuff as well. Then there is something like the Job Generator plugin, kind of like the same thing with the templates. It's a nice feature, but it's also not really flexible. Then there's the REST API or the command line interface. Here it's the same thing with the script console. You can do almost anything. It's hard to keep an overview of who is doing what, and it's also not testable, or not really testable. Then, of course, there's the pipeline plugin. But we needed this feature over a year ago, and at this time, the pipeline plugin just was not ready. And also, it's still missing a testing framework until now. Then you have the Job DSL plugin, and yeah, suddenly you have easy coding, it has a nice API, and this stuff can be tested. So that's the main reason why we chose this plugin. And let me show you a simple example, in this case for a Maven job, written in pure Job DSL syntax. And as you can see, now we have configuration as code, and you can do anything you want to do via the UI as well, set all your specific configurations. Yeah, but as you can imagine, this is way too complex for an everyday developer. So there is just simply too much stuff going on around here. So finally, this is still not what we want. What we want is, all our original questions are still not answered yet. That means the questions or the issues simply moved from the user interface now to the code. I mean, now we use configuration as code, but we couldn't resolve any of our issues. And there are even new issues, like you have a new scripting language. And to be honest, Groovy is not really for everyone. And there is also a new Job DSL reference you have to learn, and people will not do that. So what do we need to do to prevent these confrontations with our simple developers? Well, first of all, there are a few things that a typical Jenkins user should not really need to know about. Like, for example, standard log rotation. Usually you have to set this in all of your jobs, but people will do all crazy things with this. Then there are these usual configuration pitfalls, like, for example, these little hidden advanced buttons that keep some very interesting configurations for all of your plugins. Credentials for technical users. God, no, please don't. I mean, the worst that can happen here is that the credentials are coming up suddenly in your log files. You do not want that. Naming conventions. When people creating new jobs, they usually do not want to think about what a job should be named. And there's a lot of crazy plugins going on, like the Jenkins Maven plugin, and you can't, it's really hard for the people to know about all the special little magic that is going on within those plugins. And of course, default settings, like, for example, should the timestamper plugin always be activated? Should every build be claimable? Or are there standard notifications that I have to look out for? So how can you solve all these issues? Well, what we actually did is we wrote our own framework for this. And you can do this by using standard software engineering approaches to make it good. Like, for example, you can use inheritance, any standards, code convention, clean project structure, dependency management, reviews, tests, and even more tests. And this is how you can do this. Let me show you how this actually works. Here's our Maven configuration from before for the Maven job. And as we said, we now want to eliminate everything that the users should not be thinking about. Like, for example, the log rotation, JDK settings, this crazy release thingy here, the standard goals, what Maven installation. And basically it comes down to a simple configuration. Like, here you have a Maven job, and it just tells you what it actually does. And there is some checkout. And this is basically all the people care about in this job configuration. So let me show you how this so-called job builders actually work. When I started this project, I had no idea of Groovy at all. So I took a little bit of research, and I can really recommend the blog called Groovy Goodness from Mr. Haki. He has some very interesting stuff. And he told me about this builder pattern. And there are two main advantages when you use the builder pattern. One is you can write your own functions. You can write your own Groovy closures. This is how you can do it. I still haven't figured out how this actually works, but it does its job. It's fun. And another good thing about Groovy is you have the possibility to, when there is a method that is, when you try to call a method that is not defined in your own code, then you can catch this. And what we actually did is we tried to delegate all of this to the actual Job DSL job. So this makes it possible for us to achieve, we can write our own functions. For example, here we have this restrict permission function where you can pass some users or some user groups, and then all the permissions get magically restricted only to those people. And right below you can see this is the original Job DSL syntax. And what's the beauty here is you can mix this up. So you don't break the original Job DSL kind of style. These job builders are, well, the structure is very simple. The constructor takes care about what job should be created, what type of job. And then all the other part is stored within the make block. And here, you now have the possibility, for example, to set all your standards for all the jobs. For example, in this case of the log rotator, what JDK should be used every time, and what is the standard label for our jobs. And then you see the run closure. This is the point where the user configuration comes in again. So you can see here, in comparison to the standard Job DSL syntax I showed you before, this is where all the standards for your jobs can be set. And now we have our first question resolved about all these standard settings. You can build your own different sets of job builders, and depending on what they do, this is the place where you can do all the standard configuration for them. Here's again the example for our Maven Job Builder. Here you can see within the make block, this is where we store all those complicated settings that we want to be unified over all our Maven jobs, for example. And the beauty of it is the instant you call this function here, or create a new, in this case, Maven Job Builder, you have all your standards already set. This job is automatically, you can release it out of the box. It does the right deployment to Nexus or whatever repository you want. It has standard settings like log rotation, or every build is claimable. It has the right notifications set, and so on and so on. So another great feature is now you can write your own functions. And this comes in really handy if you want to prevent that users can over-configure stuff. For example, here, this is how we do some checkouts from Subversion. And this block here is usually what you have to configure for it. And what we can do here is we can strip this down to one single line of code. You do not need to know about any credential stuff anymore, or where it gets checked out, or about getting into discussions what SVN checkout strategy should be used. It's all standardized now. So why is it configured that way? Well, it does not really matter anymore because everyone is using the same functions, and all the magic suddenly disappears. And it makes it really, really handy for the users to, in this case, check out from Subversion. Another good example is we struggled with a lot with our crontab configurations. So what we did here is we write our own function for that. And what we do here is we pass an enumeration, and it's now much more easier for the people to use and also to read. You do not, and at this point, you also can finally take care about all your trigger configurations to be hashified. And this is simply what you have to do now if you want to use a simple cron setting in your jobs. Another great feature that I want to mention is there is a lot of stuff going on when people try to write scripts within job configurations, and this is usually what this looks like, and this is highly unreadable. So what you can do here is you can extract the script to a known script file and read it into a variable and just pass this variable within the actual Job DSL shell step. And another great feature of this is now that the original script is separated in its own file, you have the possibility that your IDE shows proper syntax highlighting for it. You can even do some pre-testing and have code completion and whatever. It's a really, really nice feature. So now that we have our minified configurations, it's really, really easy for the people to create their own jobs. And suddenly, people are starting to use it. They will understand it. It's pretty easy to read. You can just copy-paste stuff from other jobs and adjust what you want to do other way. And now, questions like who's responsible for this job, people do not ask this anymore because I can give this to any of you, and you know what this is all about. You just have to know what Maven is and how cron works. What is this job doing? Well, it's pretty easy to read. Everyone has a basic idea when you say, okay, here, SVN, I want to do a checkout, or I want to expand some Maven goals. It's not a real question anymore because you can store all complicated configurations within very easy functions. And of course, now that all the job configurations are within the code, you can use this as a typical software project, and you can do huge refactorings. You have now your single point of configuration, and if you want to adjust stuff for a group of jobs, it's now very, very easy. Another great feature that we encountered is our deployment job was a huge job with a lot of parameters. And so basically, it's one job that does everything. And what we wanted is we want to make every job traceable, so we have a proper history of the runtime and the test results and so on. So what we did here is we just multiplied this out, meaning we have our enumeration called dev environment, and now we can simply create little jobs in this loop over here and create jobs for every single environment. And what we did is we put every parameter back into the environment variables for this job, and the users don't have to take care of this anymore. So now the highly parameterized jobs, we broke them down to single deploy jobs. And this is how this dev environment enumeration can look like. Another great feature is if you remove or add your environments, then the whole deployment pipeline gets generated for you. As easy as that. A little bit about the project structure that we use. As you can imagine by now, this is a basic Maven job, Maven project. So there is also the typical Maven project structure here where we store all our code. Within the resources folder, we store all the actual job configurations and view configurations, and there's an extra location for all the external scripts as well. Then we have our according test structure as well. And another great feature that comes in handy when using the Job DSL is you are now able to generate your jobs locally, and you can have a quick look at how the actual job config XML files look like. So when you do huge refactorings or you try to change stuff for a bunch of jobs, just diff this little debug folder with the previous run, and now you can see what you actually did. This really comes in handy. The project dependencies look kind of like this. The main project is called DSL Builder. This is where we store all the main common builders that people have to use, or the main functions that we provide them. This has its own release cycle. And then the actual job configurations we store in different modules. And the modules are separated for every team or department of the same area of responsibility, meaning people can work independently now. It's a very great feature. And also, for example, if you want to provide them different new features, they can use simply different versions of the DSL Builder project. So now, in conclusion, we can now resolve all the previous issues we had before. What is this job doing? Well, just look at it. It's a minimum configuration. It's very easy to read. Everyone can use this. Is the job still in use? Well, now that this stuff is somewhere in the repository, just look at the commits and you have kind of an idea about what's going on in this project. Who's responsible for this job? Also, not a real question anymore, because now everyone can read this, and this stuff is stored in different modules, meaning that you kind of have a first idea where this came from. Then why is it configured that way? Well, now you have the possibility to write your own functions, and you have now simple methods for pretty complex stuff. What are the standard settings? As said before, these settings you can now set within your job builders. Who changed what and when? Well, this is, you basically get all the benefits you have when you use VCS. And of course, how to change settings for a group of jobs. Here, you have the possibility now to refactor or search and replace, have your single point of configuration. For example, you can use constants at this point to get back to my example about when the overall repository location is changed, just change the constant for it, and then suddenly it gets rolled out for every job, and you have to do nothing at all. The new scripting language, well, there's no need for that anymore because we simplified most of this crazy Groovy stuff with our custom builders and functions. And when it gets to people want to use some special settings that came from within the Job DSL plugin, if you have a look at it, it has a really nice, outstanding API viewer, so that's not really a question at this point. Our story does not end here. The thing is, people have to be able to work with this autonomously, creating their own builders or job pipelines or whatsoever. And my job as a DevOps engineer is I have to make myself as redundant as possible, so people don't need me anymore for their job configuration. They have to do this by themselves. How do we get to that? Well, the first thing I learned when I started this project is the people will do kind of the same thing in the code as they did before via the user interface. They copy-paste stuff. They copy-paste errors as well. They will write jobs in pure DSL syntax. They will not use your functions or your builders. And suddenly they're all forgetting about the standards again. And they will use anti-patterns. Some people just are not developers. They don't really know how to code. So the configuration will be unreadable again. And at this point, what do we have to do to prevent all of this? Well, it's simple. You have to write tests. And what do I mean by that? As you know, the Job DSL plugin gets used from so-called seed jobs. The C job is the actual Jenkins job that generates all of the job configurations from your source code. And what we do here is right before we call the Job DSL plugin, we do a little testing with our Maven project that stores all the job configurations before, and it also stores some tests. And at this point, this is kind of your last resort. You always have your tests to be executed right before the jobs are actually generated, meaning if you did something wrong, nothing will happen at all. This is really great. This is how you can get your people to work with this autonomously. Let me show you how you can write tests for this stuff. There are some examples, actually from Mr. Sheehan, Job DSL contributor. He has a repository called Job DSL Gradle example. Don't worry, it's kind of the same thing. It's regardless if you use Maven or Gradle at this point. What's important is he's using the so-called Spock framework. That's where this given when then syntax thingy came from. And this is how a simple test looks like. You have to mock your stuff for the Job DSL. And then you execute the actual method that's used when the C jobs are generating your scripts. And in this case, it simply does some basic syntax checking and looks that everything can be generated well. And you kind of do this for every one of your single job configuration files. What we wondered now is what can be tested at all within these job configurations. And as you probably know, job configuration is nothing more than a standard XML file. And what you can do with this is, for example, here we have a simple job that has an hourly cron tab set. And this is what the bare minimum XML would look like to give you an idea what we can do here. Now, within the actual test, let's say we want to make sure that there is an XML tag called triggers. You simply can do it this way. You can also look out for is this any kind of a specific trigger, like for example, is this an actual timer trigger? It's really easy to test this. You can also vice versa test the negative, that you do not want this to be an SCM trigger, for example, by simply negating this. Or you can even test the value of the XML tag itself. Also that you can do very specifically. And if you really want to do exactly, if you really want to test exactly what's within the XML file, you can also iterate through all single XML tags. And it's kind of crazy what you can do here, but you can keep it quite simple. What we do is we have some overall tests that will be executed any time for every configuration. And this is how you can do this. What you have to do is you set up your test by simply calling in all the actual job configuration files and convert them a little bit so the Job DSL function can do something with it. And you call the Job DSL, and afterwards every script file will be stored within the so-called job management. And at this point, you can write your tests. For example, what you can do here is we want to make sure that every job has log rotation defined. Just a simple example. And then you go to your job management, read in all the saved job configurations that you did. And so this test will go through all scripts. And there's no matter what the people did, this test has to be passing. Another example, what you can do is you can look out for specific configurations that the people will write within your shell steps. What you can do here is you go through the job configurations and collect all the actual shell script configurations. From them, you collect all the shell commands. And now you have the actual script as a text, and you can parse it. Like, for example, what we do is we want to make sure people always turn off the debug output. That's standardly active within Jenkins. And you can also test stuff like you do not want to have people using, for example, system exit from within Groovy files that shut down Jenkins, for example. It's a very bad thing. So for everything that's happening that people misconfigured, just write a test for it, and you will not have these problems anymore. And also a great feature are functional tests. In this case, we have some crazy jobs where we just want to make sure that people will never, 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 ever configure them with certain kinds of settings. Like I said, if there is a problem within the job configurations, then all you have to do now is write a test for it, so it will never happen again. This whole thing had a huge impact for all of our development teams. Here are some examples. Our web development team had a really, really huge release process, and the people had to do everything manually. Now that they finally can read and understand what their jobs are doing, they built something, and now it's a one-click release. Business intelligence, those guys had no idea about Jenkins whatsoever, and now with these simple job configurations, they automated nearly their complete processes. And in the core development, as I mentioned before, there was a huge deploy job that no one understood, even me. I couldn't figure out how this worked. So what we did is we generated some simple single-click deployment jobs for all of our environments. And it's really nice because I do not have to do anything anymore. People don't come to me and ask me how they should configure stuff. They do them by themselves. So what we achieved here is that the teams can actually work autonomously here. So overall, what are the main benefits when you do this? You can refactor your jobs without fearing anything, because the tests are executed every time, and you now have regression testing as well, and debug output when you do run the test locally. You have now reduced configuration mistakes due to functional testing, no conflicts between all the different teams anymore, a very, very easy change rollout, and now you finally have minimal configuration over maximal convention. Okay, if there are any questions, please ask now. Yep. So switching from Job DSL to pipeline, you mean?
Right, or there's still things that you
that's a good question. The thing is, you can mix it up. Sorry. He was asking about how could I replace this by using the pipeline plugin. And the thing is, you do not simply replace it, because a pipeline job still needs to have a job configured anyhow. So, well, we actually are trying to mix this up. But as I said before, at this moment, pipeline is not really testable. So it's kind of tricky, because you also, if you use this pipeline configurations, you want to make sure that people will configure this as well properly. And actually, you can let's talk afterward. It's a kind of a big. Okay, then thank you.